my name is Jeremy Browning, and I'm an application expert here at MLC CAD Systems. And when someone describes themselves as an application expert, just read super nerd. I'm an electrical engineer, and I've been using SOLIDWORKS since about 2007. And in my past position, I designed machines that made artificial DNA for drug research. I want to talk a little bit about MLC CAD Systems and what we do. We are a reseller of SOLIDWORKS, Mastercam, and 3D printers. We cover the entire southern U.S. The main takeaway I want you to have is that we're one of the most certified resellers out there. If you call in to tech support, you're going to get someone like myself on the phone who's going to respect your time and know that you have an issue. But what we're here to talk about today is online training. Now, I want you to know that online training is live. This is not pre-recorded. It is instructor-led. You're going to see exactly that. This is someone walking you through the training and not anything that is pre-recorded. You'll also get a training manual shipped directly to you. That is yours to keep. And during the training, you can ask questions at any time. It's like a conversation, just like if we were face-to-face. This is a map of our territory. Everywhere that you see a dot is a physical brick and mortar office for MLC CAD Systems. And what's great about online training is you don't have to actually be in the office to take this training. You have more available classes to you since they're all online. So let's go ahead and get started and take a look at what online training looks like.
I want to get started and show you an example of what it's like to go through some online training with MLC CAD Systems. And what we're going to do is we're going to build a ratchet. And I'm going to build a ratchet that looks like this, so I want you guys to know where we're going. You see that we got a nice little ratchet here. There's no guts inside of it. This is just the actual finished product. And the reason I like to show this is because even in a training class, I want you guys to understand where we're going and not just be led around learning features blindly. So I want you to have an idea of what we're trying to accomplish with the features that we're learning. So with this ratchet, it's comprised of three main sections. There's one right here, that's the handle. There's a neck, which is in between the handle, and then the last piece, the head. So we're going to make three separate features, learning some different tools to accomplish those features. Now, I do want to point out that we're going to build in some symmetry on this model. So you can see along the top plane that this model is very symmetric about the top plane. It's also symmetric about the right plane. So when we're designing this with our design intent, we're going to make sure that it's symmetric about the right and the top plane. So we can accomplish that with sketches, and we can accomplish that with features. So the very first thing we're going to do is we're going to sketch and we're going to model the handle. So I'm going to start brand new. I have no tricks up my sleeve. Just start with a brand new file here. I'm going to use a millimeter template. Obviously, there's no features in the tree, and there's nothing crazy going on. But the first thing I want to do is select my top plane. And when I select my top plane, I can then go to the Sketch tab and fire off an actual sketch. Now, in some lessons, we talk about different topics, and in this topic, we talk a lot about construction geometry and symmetry. And one of the things that you can do is you can use this tool called a construction line. It's also called a center line, depending on if it's used in the center or if it's not in the center of something. But we can use these to reference what we call the origin, which is our 0, 0, 0 point out in space, and then draw some shape out in space without having to dimension all the way to the origin. So what I can do is I can then fire off Smart Dimension and grab the value of this and give it a value. So in some other CAD systems, you got to enter values in different places and maybe in the properties of a line. But with SOLIDWORKS, you're going to draw the line, and then you're going to tell it how long you want this to be. It's going to be 220 millimeters. Notice I didn't type any units. That's because we're in a unitless system. You just define the units up front, and then all you have to do is type your numbers. So there's 220 millimeters. Now, when I draw a line around this construction geometry, I'm just going to draw this rectangular shape. Now, the thing about this rectangular shape is it's not closed because that construction line does not close and completely bound an area. Notice that there's an option up here, shaded sketch contours, it will shade in anything that is completely bounded, much like this circle right here. Now, this rectangle is not completely bounded because we need it on the other side as well. Now, the reason I drew it like this is because what I would like to do is select all three of those lines and then mirror those entities around that construction geometry. So by hitting mirror entities, I can then say mirror about and choose this construction line. And now wherever the one rectangle goes, the other one will also follow. So at this point, to fully define this sketch, now fully defining a sketch means that the sketch cannot be pulled any way. It is fully defined in X and Y, and we're going to do that with our smart dimension. Now I want the overall length of the handle to be 100 millimeters long. Now notice that the lines on the ends of our rectangle have now gone from blue ink to black ink. And the reason being is lines that cannot be moved are in black ink. So you see now this rectangle can only be pulled left or right. All right, so at this point I need one more dimension, and this dimension is going to go all the way across that construction line, indicating that this is the overall width of this handle. And I want that to be 20 millimeters. All right, so now our sketch is completely defined. We are fully defined. It says fully defined down here in our status bar. All of our sketch lines are now black, and we can now use this sketch for a feature. To do that, all I have to do is tell the software which feature I want. So I can go to the Features tab, and then I can fire off Extrude Boss Base. Now I do want to point out that during training classes, what I like to do is I like to go in and make sure that everyone can see things by highlighting and just circling things that might need more pointing out, and yellow is a bad color, red's a little bit better of a color. So if anybody asks, hey, where was that? Then all I have to do is circle it, and everyone can see exactly what button we're talking about. And that's that Extrude Boss Base. Now when we extrude this, I want to make sure that we're building in that symmetry around the top plane and the right plane. So I can do that by using an end condition called mid-plane. Now when I do a mid-plane extrusion, whenever I enter the value of this, I want to make sure that that is the value overall. That is not 15 millimeters on each side. That is 15 millimeters as an overall value, with our sketch being in the center. Now, if this is going to be a like an injection molded piece or a forged metal piece, then we're going to have to add some draft onto some of our faces, unless we just really want to ruin our mold the first time we use it. So we're going to have to add some draft. Now, I can add draft in a couple different ways. One of the ways is during an extrusion, and that's by activating this button right here to turn the draft on. And then I can add 8 degrees of draft. Notice that whenever we add draft during an extrusion, it's going to draft every face. So you'll see that even going back toward it, so all of these faces all the way around are getting drafted. So the last thing we want to do is draft outward. That's going to break our mold, and it's not going to be pretty. So I'm going to uncheck draft outward, make sure it's drafting inward. Then I can hit my green check, and you'll see that I now have our handle out here in space. Now, one good thing that I would strongly recommend whenever you're modeling in SOLIDWORKS, a best practice to follow, is to name your features. Because when you get later down in a model and it says Boss Extrude 37, that doesn't mean a lot to anyone. But if you were to come in and rename this feature to handle, then that tells everyone exactly what part of this model that feature goes to. So you can do that with any feature. I strongly recommend naming features as you go, rather than going back and going, okay, this is still at 37. What does that mean? You can do that, but it's just not as easy. Now notice that our origin is down here. That's because that's the only known point in space, and we use that construction line to design the handle way off in space. It was fully defined because we used the construction line to reference the origin. But now what I want to do is I want to sketch on my front plane. And when I fire off a sketch on my front plane, my camera position is going to go normal to that plane. Now, if you don't want to do that, you can always use any keyboard shortcuts, or you could move your cursor to rotate your screen, but it's perfectly good for right now. I'm going to activate a circle command. Now the circle command is 2 clicks. So you're going to click the center and then the radius of the circle. So I want to put that right on my origin. And notice the yellow box indicating a sketch relation of coincidence. So that means I'm going to put the center of this circle on my origin. And then I can click again to give it a radius or a diameter. Now I'm going to delete that first circle because we only need one. Notice that this circle will get bigger or smaller whenever you drag it. And next thing we need to do is fully define it by giving it size. To do that, I'm going to fire off the smart dimension. Now, I do want to point out that down here, there is a size dimension for these circles. I would strongly recommend that you don't enter the value there, because if you were to enter the value there, you can just simply drag it and that value gets overridden. So you can see if I add 5 to that value and then I drag it, that value is just simply overridden. It is not anything that's set in stone at all. I would recommend using the smart dimension tool rather than the parameter. So at this point, we can now give this thing a size. I want it to be 12 millimeters in diameter. The default for a smart dimension is diameter whenever you're defining a circle. Now I do want to point out that you could also go in and display as radius if you needed to. That's very beneficial whenever you need to pull dimensions into your drawing. So I would recommend that however you want your dimensions showed on a production drawing, you should put those dimensions all the way down into your sketch level. In this scenario, I just want the diameter, but I do want you guys to know that you can define dimensions as radius or as a diameter. Now I want to take this and I want to extrude this. And when I extrude this, I want it to go toward my handle. So that's going the wrong direction. I can either grab this handle and pull it that way, or I can hit this little flip direction, reverse direction button, these 2 opposing arrowheads. You'll see that my preview flips, and now it's going toward our handle. Now, I don't know what that dimension is. Well, I mean, I do if I want to math it, but mathing's hard, and I don't really want to math. I mean, don't call me lazy, call me efficient. What I want to do is I want this to go all the way up to the handle and just match that face. So instead of mathing, I can use a different, what we call end condition. That end condition, by default, is blind, which is like telling the Hulk to put on a blindfold and take X number of steps, or step X distance. And he can walk through any features or cuts or anything like that. But what I want to do is I want to say that I want to go up to next, or up to surface, or up to body. One of these is a little bit better than the other. But if I choose up to surface, and then I choose that surface, that looks right from this perspective, but you'll notice that whenever I mouse around and I rotate my view, that might not work. We could have issues with that. We could be creating a torque wrench or a single-use wrench, maybe a Harbor Freight wrench. So maybe what I want to do is have that match all the way to the handle. So this might not be the end condition that I want. Now there's 2 other end conditions that are a little bit better than up to surface. One of them is up to body. Now when I choose up to body, I'm forced to choose the body that I want it to go up to. So that's an extra click. I want a super efficient mouse. So instead of all these extra clicks and extra movement, what I can do is I can just say up to next. And it just goes up to the next faces and says, cool, I'm done. I can then hit my green check mark to accept that feature. And instead of Boss Extrude 2, I want to rename this feature to neck. This is the neck of the ratchet. So notice that when you're renaming your features, it is very beneficial to be able to see that and go, okay, I know exactly where that is on the model. Now the next thing that we're required to do in this design is create the head of the ratchet. Now this is probably the most complicated section of the ratchet. Even though it's not that complicated, it's a little more complicated than a rectangle and a circle. In reality, it's just 2 circles with 2 lines. So I guess you could break that down to 2 lines and 2 arcs. But what I want to do is sketch that on the top plane. And the reason I'm sketching that on the top plane is because we're building in that symmetry. Just like I did for the handle, we extruded in a mid-plane extrusion so that we're building that symmetry. I'm going to do the same thing for the head. So on the top plane, fire off a sketch, and then I'm going to sketch the head shape out here. Now, one thing that I like to do sometimes is draw my shape out here, fully define it, and then snap it into position. And that's what we're going to do for this head. So I'm going to draw with a line. Now, whenever you're drawing a line, when you complete that line, notice that SOLIDWORKS is a click operation. It's real clicky like a high school. Not that it's bad, but whenever you come back and you touch that end of the line, it's going to turn it into an arc. So it's automatically switching from the line tool to the arc tool. So what that means is you could come back and turn it off by touching the, oh dang, it didn't turn it off. It stayed at an arc. So instead of coming back and touching it and turning it on or off, you can hit the A key, A for arc. So notice that it's still in our line command. If I hit A for arc, it then goes to that arc command. So you can very quickly draw shapes that require lines and arcs. So pretty quick you can draw any shape you want with a line and arc. Now I want to draw the head of this ratchet. Now I want to reference back to this completed ratchet. And if you'll notice the shape of this ratchet, it's an arc with a line and an arc and a line. All right, so it's not terribly complicated, but that's the shape that we're going to draw. So on our sketch tab, I want to fire off a line, and then I'm going to go straight up, hit A for arc, come all the way over, and use my blue inferring line so that the endpoints of these arcs are horizontal with each other. And then I can ride down this yellow inferring line until I see my blue inferring line, indicating that I am tangent with the arc that I was just drawing, but I'm also horizontal with the start point of that first line. When I see that, I can click again. Now it's still in our line command, but I want to go back to an arc so I can hit A. Now, one thing I see people doing is holding down A. Don't do that because then it just swaps really fast between line and arc. That is definitely not what we need to do. So just make sure that you're not holding down A. Now, I'm going to go back to arc, come all the way back around, and then what I can do is turn on my sketch relations. So I can turn these things on right here. Sketch relations look like a little perpendicular symbol. And notice that I have a tangency there and I have a tangency there. I need 4 tangencies, so I want to make sure that this point, and starting in 2019, you can click on a vertex and choose Make Tangent. You'll see that that tangency then pops up. Because prior to that, you had to choose a line, hold Control, choose the arc, and then you can make that tangent, or you can add the relations over here in the property pane. Either way, I now have 4 tangent relations. Then I can draw a center line between the 2 centers of the arcs. Now the reason I like to do that is because I have a handle. I can have something like dimension. I can yank this shape around with this construction line. It gives me something that's a little bit easier to dimension as well. Plus, I can choose this line and I can add a relation to the line. I can say that that line is vertical, which then forces the 2 arc centers to be vertical. So that's perfect. That's exactly what I want. I'm going to turn off my sketch relations because in a more complicated sketch, now this isn't a complicated sketch, but in something a little more complicated, there could be a ton of sketch relations. So I'm just going to hide them, and it looks a little bit cleaner. Now I can dimension this thing. I want the overall height from center to center. I want that to be 12 millimeters. Then I want to define the radius values or the diameter values of these 2 arcs. Well, the default for a complete circle is a diameter. So that's the default dimensioning scheme. But if you don't have a complete circle, the default dimensioning scheme is a radius. So this one is going to be a radius of 13. But if you wanted to show this still as a diameter, you could still swap this and display as diameter. So that way you don't have to multiply or divide by 2, because that can get complicated sometimes. Maths are hard. But this bottom radius is going to be a radius of 16. Now, this is a fully defined sketch, except for the fact that it's not. How's that for circular logic? So you'll see that I can drag it around, and it moves in and of itself, and it doesn't distort. That's kind of the key to a sketch. Like, does the sketch distort? A lot of times in training classes, I'll have people ask, hey, is this sketch right? And when you look at it, it's still blue, so I ask them to drag a vertex. When you drag a vertex, If it stays in the same shape but just moves, you're probably headed down the right path. Now, I want to take the center point of this bottom arc. I'm going to hold Control, and then I'm going to grab the origin of our model. And when I use Control in SolidWorks and select multiple things, it allows me to add sketch relations, or inside of an assembly, it will allow us to add things like mates. But here in a sketch, it will allow me to add sketch relations. Now, sketch relations are going to hold things together. It's like the glue inside of a sketch that hold all of your sketch entities together. So I want those 2 points to be coincident. So they're just going to be smack dab on top of each other. You'll see all of our blue ink went to black ink, so now we're good to go. In our status bar, it says fully defined. And at this point, I can now use this sketch for an extrusion or a cut if I needed to. In this scenario, I wanted to extrude it because we're creating the head of this model. Now notice it goes blind, and I don't need the blind extrusion. I want to build in that symmetry. So building in that symmetry, not only in the handle, but also here in the head. So I'm going to change that end condition to midplane. Now, when I'm extruding this, again, remember that the overall height of this when using a midplane end condition is the overall height, not from your sketch plane out. So I want this to be 20 millimeters, and I'm going to add draft here as well. So I'm going to say, hey, you know what? I want some draft. I want 8 degrees of draft on this one as well, and then hit my green check. So you'll notice we now have the head of our ratchet. One thing I want to point out, that when I edit this feature, when it's extruding, notice that we went around the shaft of that neck. Now, what happened to all that material inside? Well, there's this green check. There's a check box that says merge result. If you were to not merge that, then what you're going to do is you're going to get 2 separate bodies. You'll see that there's a neck body, and you can kind of see it inside of there, and then there's also the head body. Now, I don't necessarily want that in this scenario, but that is something that you could do, especially if you're designing something like manifolds or something that creates cavities inside of other geometry. In this scenario, I do want to merge that result, and I want to make sure that all blends together. Now, you can check that by hitting this tool called the section view. And if I were to section this model, you will see that now this is one solid piece of material, versus if we were to not merge that result, then it would be 2 separate chunks of material. So definitely 2 drastically different results from a tiny little checkbox. So be cognizant of whether you're merging results or not. Now, to turn the section view off, all I have to do is hit the button for section view, and it turns it right back off. Now, I do want to rename this feature. We're going to rename this to head. So now you'll see that we have our 3 extrusions, and we have our handle, we have our neck, we have our head. Now, this is how we're going to show our model if we're going to get it forged out of metal. Maybe we're going to get this like cast steel or cast aluminum or whatever you're going to do to get this ratchet manufactured. But once it comes off the forge, we're going to have to show this in the machine state, right? So we're going to have to pull these into maybe a CNC, maybe a whole batch of them, and we're going to have to mill out the area for the ratchet internals. So let's tackle that now. So I want to create a recess where we have a piece of sheet metal that can cover all the internals so we don't get any dust in there, and it protects all the gearing, and we can keep it all nice and greased up. So in this space right here, I'm going to fire off a sketch. So I'm going to go to the sketch tab and hit the sketch button. Now, again, it takes me normal to my sketch. That's like opening a notepad and saying you want to draw a picture. The first thing you're going to do is probably turn it towards yourself, normal to your view. If you're not, then you're just kind of drawing blind, like some of those challenges where people are drawing on each other's backs. So we want to make sure that we're not drawing blind. We want to be looking directly at it, and that's why our view changed to normal. Now, I could sketch another shape in here. If my design requirement was such that I wanted a 2 millimeter offset from this existing edge out here, I could sketch that and I could dimension it. But let's not work too hard. Let's only work hard enough. Let's work hard enough to get our job done. So what I can do is I can come up here and use this tool called Offset Entities. Offset Entities will take an edge of any highlighted face, like what you see here, and will offset all of those edges in one direction or another. So you see right here, it's a 10 millimeter. I can hit this reverse direction, and it will come inward, which is the direction that I want. But I want a 2 millimeter offset. So entering my value of 2 millimeters and accepting that command, you'll see now I have a fully defined sketch, and it's even driven with a dimension. So at any point, I could double click that dimension, and I could change that offset value. So it's very easy to create and modify offsets. Now I want a 2 millimeter cut. So we went 2 millimeters in, and now I'm going to cut down 2 millimeters. Maybe we have a piece of metal. Our cover is a 2 millimeter thick piece of metal. So we need to create a pocket for it, and we're going to call this the recess. So I'm going to hit Features, and we want to remove material this time. Up to this point, we've been adding material, and now we're going to remove material. So Extruded Cut. This one is going to be blind because I know for a fact that it's 2 millimeters. It's a fixed size, so it will always be 2 millimeters. So I can then hit my green check mark. Again, we're going to call that the recess. And so R-E-C-E-S-S, one of those words I spell wrong all the time, so I just kind of say it like Mississippi. But anyway, we have handle, neck, head, and then we have our recess. Now, I want two massive circular holes. If we go look at our completed ratchet, you'll see that we have these two circular holes. Now, these circular holes are going to allow us to put all of our gearing in here. And when we put our gearing in there, we're going to need that space. So we're going to have to remove that material so that we can actually add our gearing. So we're going to have a ratchet area and a wheel area. Now, to create this, what I need to do is create two circles and then remove the material in between. So let's jump back over to our in process or in work ratchet. I need to create a sketch right here. And when I create that sketch, again, it's going to go normal to my view. I can zoom in. I can then put a circle. And I want to do something that's called waking up the center point. When I wake up the center point, all I have to do is hover my cursor over the edge. And then it will divulge the center point of that edge that you're then hovering over. So then I can use that for a coincident relation to put this circle. I can then come down here, and the center point of this was actually the origin, because that's that sketch relation that we created. So whether you wake up the center point or whether you use the origin, either way, they're in the same spot. So I'm going to make a coincident relationship right there, and then go ahead and place it. Now, all I have to do again is to define these in shape. So their position is defined, just not their size. So this is going to be an 18 millimeter diameter circle, and this one is going to be a 24 millimeter diameter circle. Now, I want to remove that material inside. So if you're talking about a Venn diagram, I want to remove the section in the middle that's the same. Now, whenever we're talking about Venn diagram, all I can think about is Venn dieselgrams. You guys probably didn't know that there was such thing as a Venn dieselgram. It's just like a Venn diagram, but a little more complicated. So does everyone remember what Vin Diesel looks like, right? If not, then Google it really quick on your phone and look at Vin Diesel. And then I want you to understand what a Vin Dieselgram looks like. So if The Rock and Joe Pesci had a baby, he would look like Vin Diesel. The longer you look at it, the scarier it gets. So go ahead and lock and load that one in your back pocket so you can discuss it at the water cooler with your coworkers. So just take that one and do with it and do what you will with it. But what I want to do now is I want to use this tool called Trim Entities. And I can use Trim Entities to get rid of Vin Diesel. All right, so we can just get rid of that, and now we're left with The Rock and Joe Pesci. Now, the trim command is really awesome. I like the trim command a lot because you can take any lines that you might have, and you can use the trim command to either extend or to trim away. So in this scenario, maybe I wanted to extend that one and then trim it away. And that's exactly what the trim command does. So you can see just dragging through things allows me to remove. And then I can always drag back through these little red boxes, and it will bring back, it's like doing a Control Z on your trim. So you can see really quickly, I can get an enclosed area using that trim command. All right, so I like the trim command a lot. I use it very often, and it allows me to extend or trim closest or nearest all in one tool. Okay, so now we have our completed shape here, and what I want to do is use that for a cut. So let's go Features, Extruded Cut. We're going to cut down into our model, but this time we're faced with a different challenge. What if you don't know the height of this head? Maybe it's a variable height, and we don't know every time what it's going to be. So it's not necessarily that we don't know how to math, it's the fact that we don't know every math option available for this ratchet. But what we do know is that our design intent says that we need a 5mm wall left over after this cut. So maybe the engineers that stress tested this said, hey, we have to have a 5mm wall, otherwise this thing's going to just break and work. So what we can do is we could turn on the measure tool and we can measure that distance and then subtract 5, and then we know how deep to cut it. But I don't even want to do that. I want to take this and I'm going to make it a little bit more intelligent. I'm going to change this end condition from blind to offset from surface. When you choose offset from surface, I then have to choose the surface I want to offset from. So I can choose this face, and then this value is the leftover wall thickness. I can make that 5, and then I can hit my green check mark. You'll notice that it just has a cut in there, but what we can do is I can turn the section view on, and you'll see that there is in fact material left. We can go to the Evaluate tab, and we can fire off the Measure tool. With the Measure tool, it looks like a little tape measure, go figure. I can choose a face, I can rotate around, and I can choose another face, and then it's going to give me the actual distance from one to the other. Now notice I'm in inch template, so I can hit the INMM, say Use Document Settings. You'll see I'm now 5mm away, which is exactly the value that we specified during that feature. So let's turn this back off, and I want to rename that feature, and that's going to be our pocket. All right, so we remove material for all of our gearing inside this ratchet. And now I need some holes back here. So I need a hole that holds everything in, and then I need maybe a hole that disconnects our ratchet so it doesn't, you don't have to yank it off there. So I need a ratchet hole and a wheel hole. Now I want those to land on these faces, and I'm just going to fire off a sketch. And then I want to put a circle down here. Now this one, I'm going to wake up that center point on this this arc, or that radius edge. And I want this to be some size, and in this scenario, our wheel hole is going to be 9mm. So that's a fully defined sketch. I can now take that and I can do an extruded cut all the way through. That's exactly what I want. This time the end condition, instead of being blind, is going to be through all. Now notice a blind end condition of anything 5 or greater is technically a through all. But design intent says that you should do a through all rather than a blind, because what if someone comes back and says, hey, we found some problems out in the field and we're going to have to increase this thickness. The last thing you want to have to do is go back and make sure every single value is accurate. So what I can do is say through all, because my design intent says I need that to be through the material no matter what. So that's perfect. I can hit my green check, and I want this feature to be named wheel hole. Perfect. Now, there's a way that we can expedite this process. I could choose this face, I could do another sketch, but another thing that I could do is I could simply just drag this onto that face. So I'm dragging our wheel hole back onto that face. Now it's going to ask us what we want to do with the relationship inside that sketch, because there is that coincident relationship. So we can leave them dangling or delete them. In this scenario, I'm going to say delete. But you'll see that I get another hole that landed on that face. I can then call this a different feature name, ratchet hole. Now these are two independent sketches and features. So notice it has a separate sketch number. That means they are not tied together. So at any point, I can go edit the sketch, and I can give this a relation back to the origin. So now that it's fully defined. Because best practice says we use fully defined sketches at all times. Now all I've got to do is exit the sketch and make sure that it's in position. One thing I did miss out on, though, is the size. So I can double click the feature, and anytime you double click a feature or you double click a face, it will show all the dimensions used to make that face. So I can then double click that 9, and I can change that from 9 to 12 to make it a little bit bigger hole. And then I'm just simply rebuild the model, and you'll see that we now have a larger hole for us. Now, one thing that we might need to do here is we might need to add some fillets. Now, if you're first learning SolidWorks and you call into support, don't call it a fillet. You're just going to make me hungry. It is called a fillet. Now, unless you're really talking about fillets, like, I don't know, an 8-ounce fillet sounds real nice. It's almost lunchtime. But it is called a fillet. So please don't call it a fillet unless you just really want to make someone hungry. So we're going to add 3 different types of fillets. Okay, so the fillet is on the Features tab. We're going to fire off fillet. Now, when you fire off the fillet, there's a bunch of different types of fillets that you can do. We're going to talk about a normal, constant size fillet. Now, there's also variable fillets and face fillets and full round fillets, but right now we're talking about a normal, constant size fillet. Now, if you're doing a manual fillet, you can only do one size fillet at a time. If you were to find yourself in a scenario where you need to add a bunch of different size fillets at one time, you could fire off the Fillet Expert and you could add a bunch of different sizes at once. But for right now, let's talk about the manual fillet, and it's a normal constant size. So I want to do a 3mm fillet. And in this 3mm fillet, we found that the guys out in the shop, they were cutting their hands. So we need to smooth off the handle of our ratchet. That way, it's a little bit smoother. We don't have anybody out in the shop bleeding, so you know that's safety. That's still a thing. So we need to make sure it's not sharp. Now I need another fillet because, well, let's rename that one first. It's going to be handle fillets. And then I want to make sure that this edge is rounded off as well. So notice that there's an edge that goes all the way around. But notice that it comes to an apex out here. And the reason being is we added that draft for our symmetry of this model. So when I fire off a new fillet command, I want to make sure that our fillet is the right size, first of all. I want this to be a 1mm fillet. And I want to choose that edge right there. But when I choose that edge, I want to make sure that this option tangent propagation is on. Because this edge and that arced value, or that radius right there, is tangent together, and that radius is tangent with that flat edge and goes all the way around. So when I choose this edge right there, because of the tangent propagation selection, it goes all the way around. Notice what it looks like without that option selected. I do want tangent propagation, which it just makes it easier for me as well, because then I can just come down here and choose the other side, and you'll see at that point it goes all the way around. The reason it doesn't go all the way around with one click is because those aren't tangent. It's just plain and simple. So that vertex stops that tangent propagation. So then I can choose that edge, and I can choose this edge. Now both ends of the handle are filleted. Now I also want to come over here and add a fillet to the head of our ratchet to make things nice and smoothed off. So I can hit my green check, and I can rename this fillet to HN fillet. Perfect. Now we're getting pretty close here on this ratchet. So I want one more fillet. And this fillet is going to smooth out the transition from the neck to the handle and from the neck to the head. Now, when you fire off fillets, typically you're always going to choose edges, typically. There are some scenarios where you're going to choose a face. Now, the difference between choosing an edge and choosing a face is when you choose a face, you're grabbing every edge of that face. So rather than choosing that edge, rotating around, choosing both edges where the neck meets the head and the handle, I can fire off a fillet, and I can do a 2mm fillet and then simply choose that face. Because again, when you choose a face for a fillet command, it's going to choose every edge all around that face. So I can accept that, and then I can rename this fillet to be neck fillet. So we now have our completed ratchet, and we've talked a lot about symmetry. We've talked a lot about draft as well. I do want to point out one more thing, that if you have different lengths of ratchets that you design, and maybe you want to show this to the person who's going to create the forge, and also show it to the guy who's going to machine the pockets, you could create something called configurations. So there's a configuration manager here, and I can leave default in there, but I can then create a brand new configuration, and we can call this forged. And if I hit forged, what I can do is I can suppress a feature. Now, suppress is like a soft delete. It's like when you want to run, but you don't really want to run, so you yog, so it's kind of running. That's like what a suppress is. So a suppress is a soft delete. That's like telling your kid to go sit in the corner. You don't want them to leave, but you also don't want to hear them for 5 minutes. So we're going to take all of these features, we're going to hit this down arrow, and we're going to suppress them. So that's in the forged. Now we can add a machined configuration. So I'm going to add a new configuration called machined. Now in the machined, that's where I want to show all of these, so I can then unsuppress those. So at this point, I now have forged, which has all of our cuts gone, and I have our machined, which has all of our cuts active. Now, you can do that with not only features, turning them off or on, suppressing or unsuppressing. Notice that I didn't delete those features, and if I were to delete the features, then they're gone for the whole model, and I can't use them anywhere else. If you suppress them, you can then use configurations to hide or show them depending on what you want to show. If you haven't been to our website for online training, I would strongly recommend you go there. And this is what it looks like. This is our MLC CAD Systems website. It's mlc-cad.com. And there's training up top, and you can go to the SOLIDWORKS training or Mastercam training. And you can also read up on how this online training works. But at any point, you can say, hey, I want to find like some simulation or maybe some weldments training. And you want to see when we're having the next weldments class. So you see we're having one in Dallas, Atlanta, Austin, and Stillwater. So there's a bunch of classes that you could attend. You could filter by class, you could filter by location, but at any point you can click on this and then say, hey, you know what, I want to sign up for this class. So if you want to come take this weldments class with probably myself, then you could say view weldments syllabus, and it would show exactly what we cover in that class, lesson by lesson. And then you could also sign up. So just note that what we talked about here, the ratchet, is just one lesson of 14 that we cover in SOLIDWORKS Essentials. So there's a bunch of classes out there that we host, and if you're interested in any one of those, then let us know.
We got several people following along. A couple of people were having trouble dragging that hole to make a copy of it. It was instead moving the hole instead of making a copy. Do we need to hold the control key down when we do that one?
Absolutely, absolutely. So if I go delete this ratchet hole, and I'll redo that one real quick. And also just note that in online training, if someone misses a step or anything like that, then it's really easy. We'll just go redo it. It's not a problem. So yes, if you just drag it, then that's going to be an issue. It's going to give you that try again symbol. You do have to hold down control. I apologize, I did neglect to mention that. You hold down the control key, and then you're going to drag whatever feature you want to whatever face you want it to land on. And then I'm going to delete the existing relations, and then all you got to do is edit the sketch and then reposition it. Just make sure you're editing the correct one. Reposition that hole to right there, and then resize it as well.
Yeah, I thought it would be interesting to let everybody know and see if you wanted to comment on it as far as pace. this pace is pretty close to what you would probably teach a normal class. Is that correct? And then obviously the exception being that there would be a lot more verbal discussion and interaction, and there'd be a lot more checking in on people's progress. Is that fair to say?
Absolutely. I would say that this is a little bit quicker than what we would go in an online class, because you're absolutely correct. I'm going to ask people, so hey, Marcus, are you good with that feature? Do you have any questions about that feature? And if you need to show your screen, then we'll switch over and make sure that you're following along and you didn't have any questions or missed a step, much like that, the control drag for a feature.
Yeah, so to do this, you'd want to have probably dual screens, one for the screen to see your screen, one to be able to run your own, and then you'll also have the book sitting on your desk, correct? So you'll have a reference to refer back to at any step if you need to go and kind of work behind or catch up on anything, correct?
Yeah, absolutely. Triple screen, but one of them is a book.
Yeah. And then those configurations, those I don't remember those being in this lesson. Do you kind of throw in some bonus content to some of these lessons, kind of just things that you think are appropriate or that would be helpful for depending on who is in your class?
Yeah, absolutely. A lot of times the questions and the conversation kind of steers us to talk about things that are not necessarily covered in the book, but things that are really important to know. Another one of those examples is whenever we're doing the line and arc feature, one thing I like to talk about, and I typically talk about this in an essentials class, is whenever you need to dimension a virtual sharp, something that's not in the book at all, but you could fire off a smart dimension, right click, choose find intersection. Now it's asking you with what, and then you can choose that, and you'll see you have a virtual sharp out there that you can now lock and load as a dimension. That's another one of those examples of something that we like to talk about, and usually I'll ask, hey, does anybody do sheet metal and you have to dimension virtual sharps? Anybody have a challenge with it? That can get tough. So we talk a lot about tips and tricks and then things that aren't necessarily covered in the book and things that will meet everyone's need. So absolutely, we cover things that aren't necessarily in each lesson to make it better.